Problem 16. A vertical trapezoidal gate in the face of a dike is subjected to seawater pressure of specific gravity 1.03 on one side. The upper edge is in the water surface and is 1.5 meters long. Two edges are vertical and measure 1.8 meters and 2.7 meters each. Determine the total pressure on the gate and the location of the center of pressure center of the gate with reference from intersection of the 1.5 meter edge and the 2.7 meter vertical edge. So determine the total pressure on the gate and the location of the center of pressure of the gate with reference from the intersection of the 1.5 meter edge and the 2.7 meter vertical edge. So let's have the figure. So let us say these are the two vertical edges. The horizontal top edge flush with the seawater surface of specific gravity 1.03. So with reference to this corner here, we locate the center of pressure. There are two areas to be considered. So let's divide the area into this manner. So that this is 0.9, 2.7 minus 1.8. So the rectangle is 1.5 by 1.8. Then since the top edge is flush with the liquid surface for the rectangle, 8 sub Cp is readily known. It is 2/3 of 1.8 or 1/3 of 1.8 from the bottom. So that's the center pressure for the rectangular area, 1.2 meters, 2/3 of 1.8. There's no need to compute, or if you want to compute, it is equal to zero point 0.9 half of 1.8 plus EV of rectangle. If you want to derive it, then you can still show that it is 1.2. By this time, you should have known that it is automatic 2/3 of 1.8 because we experienced that for so many problems. Then, for the triangular part, we had to compute. So, we know that they are not vertically aligned because the figure is not symmetric with respect to the vertical axis. So, we draw a line through the center of pressure of the triangle, and we call that L. The location of center of pressure is at the center of that line. So L over 2 from the right or from the left. So from the right, L over 2. But we have to solve for EV of triangle first. EV of triangle. Then this is the center of pressure for the entire surface, and here acts the total pressure or F. So this is where the F of rectangle acts at the center of pressure, not at the centroid, remember. Then this is where the force due to triangle acts, and this is where the resultant or total pressure acts F. So that's 8 sub Cp, and let's call this distance x sub Cp. So let's also solve x sub Cp and 8 sub Cp by Varignon's theorem. So Fr is 1.03 times 9.81 specific weight. Barred H is half of 1.8, which is 0.9. Then the area of the rectangle is 1.5 by 1.8. 0.9 is the barred H of the rectangle, half of 1.8. So Fr is 24.55 kilonewtons. While for the triangle, the barred H of triangle is 1.8. This is 1/3 of 0.9. 1.8 plus 1/3 of 0.9, 2.1 barred H. So F of triangle is 1.03 times 9.81. Barred H 2.1. Area 1/2 or 0.5 of 1.5 by 0.9. So F of triangle is 14.32 kilonewtons. Then F therefore is 24.55 plus 14.32. So the total pressure or the force is 38.87 kilonewtons. Then for the second question, we need to solve for ISA VT first. So EVT of triangle is height of triangle square over 18 barred H. We know that already from the preceding example, or you derive that. BH triangle cube over 36 over area 1 half BH triangle times VAR H. You can derive that easily. So it is equal to 0.9 square over 18 times 2.1. VAR H of triangle is 2.1. So it is equal to 3 over 140 meter. So that the length L is, so if this is 0.3 centroid of triangle from the top, then its distance from the bottom, the centroid distance from the bottom is zero point 0.6. So therefore, this distance of the end of the L from from the pointed end is zero point 0.6 minus EV of triangle. So L as to 0 0.6 minus 3 over 140 is equal to 1.5 as to 0.9. So that L is 27 over 28 meters. So remember, this is L over 2. So we compute the moment of the components, rectangle and triangle, with respect to the right edge so that we can solve x sub Cp by Varignon's later. So moment with respect to the right is f of rectangle. Of course, it acts here, so this distance is half of 1.5. 24.55 times 1.5 over 2 plus f of triangle, which is 14.32. Then its distance is half of L. 14.32 times 27 over 28 over 2. So the moment of the components about the right edge is 25.32 kilonewton meter. Now, by Varignon's theorem, this moment is also the moment of the single force 38.87, and its moment arm is x sub Cp. So therefore, 25.32 equals 38.87 times x sub Cp. This is statics principle, so you might wonder how I arrive with this. This is statics, so you should have known this already by Varignon's theorem, so 0.6514 meter. Finally, we also compute the moment of the components about the top to solve for x sub 8 sub Cp. So the moment of the components about the top would be Fr 24.55, its distance is 1.2, while for the triangle it is 14.32, its distance from the top is 2.1, barred h of triangle plus EVT, that's the distance of this CP of triangle from the top. Barred h 2.1 plus EVT, which is 3 over 40. So 14.32 times 2.1 plus 3 over 140. So moment of the components with respect to the top is 59.84 kilonewton meter. And that is also the moment of the resultant, which is F times 8 sub Cp. So 59.84 equals 38.87 times 8 sub Cp. So 8 sub Cp can now be computed 1.539 meters. So that's it. I hope that you're able to follow the solution and the explanations.